Welcome back. We're going to start going over one of the topics that I know students find difficult. So give yourself time to go step by step through problems. Don't try to rush. It's easy to make mistake on these exponent problems, but if you understand the rules and take it slow, you'll be okay. So the little bit of kind of bad news here is there's a bunch of rules we have to memorize, and I want to say just one thing in defense of rules, and that is rules are tools for us to use. Okay, I'm going to show you, so here's the first rule. I'm going to show you with each rule why the rule is true, and you'll see that if I were to not have this rule and have to do the problem by working it out down to the last detail, it would take a lot longer. So rules are tools that make our life simpler. Now I've put a warning up at the top of this section. Do not make up your own rules. And that may seem like kind of a silly warning. I mean, why would you make up your own rules? But here's what I mean. Sometimes people don't memorize these rules, and then what happens is they're kind of guessing at the rules, and when you guess at a rule, you end up making up your own rule, oftentimes, one that isn't actually a true one. So to keep yourself from accidentally making up your own rules, please do memorize these 6 rules for exponents, and we'll have another one a little later too, but for sure memorize these and the one I'm going to give you in a little bit. Okay, so the first one says a to the m times a to the n works out to be a to the m plus n. So when you're multiplying the numbers, remember, when there's nothing between two things in algebra, there's an invisible multiplication dot. So this is saying when I multiply two numbers, it's the same as adding the exponents. Now why would that be? Why would a multiplication of numbers turn into an addition of exponents? Well, let's look at an example to help us understand. What a squared means is a times a, right? And then what's happening next, remember there's an invisible multiplication dot there, so I'll put that in over here as well. I'm multiplying by a cubed. What is a cubed? What does that mean? Well, the exponent tells me I have 3 factors of a, right? So I've got 2 factors of a from the a squared. I have 3 factors of a from the a cubed. When I've written them all down, how many factors of a do I have? I've got 5. 2 plus 3 more is a total of 5. So the short way to write that is a to the 5th. And sure, with a squared times a cubed, I could just do this to get the answer. But what if this had been a to the 200 times a to the 39? I wouldn't want to write out 200 a's and then 39 a's to come up with my answer. I want to know this rule. Okay, so now I'm just going to say one more thing, well, 2 more things before we go on to the next rule. First, if you really understand what's going on here, it almost doesn't feel like memorization. You know, if you really understand that you're stringing m factors of a together with n factors of a, so the number of factors of a you have is m plus n of them, you know, it just, the rule makes sense, and it's not like, oh, I'm just memorizing this random thing I don't understand. It almost feels like I understand it enough that it's not really a memorization. That said, make sure you can, you know, list or recite the rules, because you want to remember what rules you have versus what rules we don't have. And that comes back to not making up your own rules. Okay, so then the second comment before we go on to the next rule is that in order for this to work, the bases have to be the same, right? It's a in both cases. It's not a to the m times b to the n. You have to have the same base for this to work, right? If I wrote a times a over here, and if it had been b cubed, b, well, I couldn't combine a's and b's and say I have 5 of the same thing. Okay, so when these rules have the same number in both places, it has to be that way. That's not just because I didn't feel like typing a different letter. Okay, enough said about that one. Let's go on to the next rule. This says if I have a to the m and I raise it to the n power, what's going to happen is it's going to be like multiplying the powers. And again, this makes sense once you understand what's going on, and understanding then will make it easier to remember. So let's do an example with some actual numbers in there. This cubing on the exponent, or sorry, this cubing on the parentheses means I have parentheses times parentheses times parentheses. What's in the parentheses? A squared, but what is a squared? A squared means a times a. Now, these parentheses aren't actually doing anything. They were just helping me visually figure out what was being cubed. So let me just point out that, you know, when in algebra, when we have parentheses next to each other, that just means there's multiplications there. In other words, this is the same thing as a times a times a times a times a. 2, 3. And if you're thinking to yourself, oh, that sounds like the associative property, you're absolutely right. So how many factors of a did I wind up with? I wound up with 6. Why? Because I had 3 times 2 factors. So I wrote 2 factors down 3 times. 2 times 3 is 6. Similarly, if I write m factors down n times, the total number of factors I have is m times n. Okay, the next rule. If I have a product raised to a power, both factors get the power. And I should probably mention this works for as many factors. You don't have a lot of room to write there. Maybe off to the left in the margin you can fit this in. As many factors as necessary, this works for. In other words, if I had a, b, c, d to the n power, I'd have a to the n, b to the n, c to the n, d to the n. Okay, so why does each factor get the power? Well, again, if I have parentheses raised to the third power, that means I have parentheses times parentheses times parentheses. What's in my parentheses? In this case, it's a product. So that product gets multiplied 3 times. And I'm going to go ahead and use the associative and commutative properties to point out that this is the same thing as a times a times a times b times b times b. Right? The associative property says I can regroup things. I don't have to keep each individual pair of a and b's grouped. And then the commutative property says I can write the factors in any order I want. So if I write it that way, I can see that I have a cubed times b cubed. Okay, so there's an example of our rule and an example of why it's true that each factor in the parentheses gets the exponent. Okay, I think I've been talking about these rules long enough, so I'm going to stop the video here and we'll come back and we'll talk about some more rules.